Math 3, Unit 4, Section, I think for us it's actually Section H. It's whatever. Okay, you'll find it. Okay, so we're going to first solve this algebraically. And so whenever you're solving root equations algebraically, you want to try to get the root by itself. In this case, if you see, it is by itself, correct? And so what do I do now in order to get rid of the root? Good. So we're going to square both sides, because when we square a square root, it gets rid of the root. And so I end up with x plus 2 equals x squared. So now in order to solve, we need to, since I have a squared term, you always want to keep that term positive. And so I'm going to move everything to the right is correct. So I'm going to subtract x and subtract 2. And so we write this out, and we have x squared minus x minus 2 equals 0. You can have the equals 0 on either side. So in order to solve this, what would I end up doing now?
Add 2 to the other side.
No. Perfect. So what multiplies to be negative 2 and what adds to be negative 1?
Negative 2 is positive.
Very good. So we're going to go x minus 2 and x plus 1 equals 0. And then when we set each of those equal to 0, I find that x equals what?
2.
Good. Positive 2 and negative 1. And whenever you get two answers for your equations here with roots, you always want to plug them back in. Now, when I look back at this, could I have a square root and end up getting a negative 1 answer? No. And if you look at it, and we can write this out, so if I'm doing kind of my check right here, the square root of negative 1 plus 2 equals negative 1. The square root of, oops, that ends up being a positive 1, cannot equal negative 1. Do you guys see that? Yes? So negative 1 does not work. So we can check 2. So we have the square root of 2 plus 2 equals 2, square root of 4. And does the square root of 4 equal 2?
Yes.
Yes. So the answer is 2. So what that means is if I were to graph these equations, each side of the equal sign, that the point that they intersect should be at 2. Okay? And so let's start by graphing. Well, we could start by graphing this one. It's a line. Okay? Because remember, y equals mx plus b. If you just have a plain x term, it's a line. Okay? And so what would be my b value on that?
0.
So since there's nothing being added to the end, my y-intercept would be 0. Oops. So I'm going to make a point here at 0. And then what is the slope? What is the number in front of the x? 1. So my slope is up 1, right 1. And you could do a few to make sure your graph is accurate. And you remember you can also go negative 1, because two negatives also make a positive. Good. So I'm going to go ahead and draw my line here. Try to at least. Okay, so there's one graph. So now we're going to graph the square root of x plus 2. And based on what we learned last time with like our functions and shifting, what would be my vertex on this? Good, negative 2, 0. Because remember, whatever's under the root is like under parentheses or in parentheses, and so we do the opposite, and there's nothing being added at the end, so that's a 0. So we'd go negative 2 up 0. Okay, then we could plug in values like a t-chart if we want to, or we could find our x-intercept or y-intercept. Does anybody have an opinion on what they like to do better? Just plug in some values. So if I were just to plug in some values, what would be a good value to plug in here? 2. So if x is 2, what is the square root of 2 plus 2? 2, right? Because you have the square root of 4, and the square root of 4 is 2. So that means there's a point at 2, 2. So we're going to go 1, 2, up 2. And do you notice how those end up actually intersecting right there? Which is kind of nice. But we'll go ahead and draw our root equation. And so down here it says f of x equals g of x at x equals 2. And if you can see here, the two lines intersect at the value where x is 2. Are there questions? No? Does this seem difficult? A little bit? Okay.
Let's move on.
What?
We're good.
Okay, let's try this next one. So why don't we start by you guys solving this algebraically? Can you do that? So once you get the answer, raise your hand and I'll come around and check it. You squared the negative as well, so it's going to make that a positive. You're going to have to... Okay, I'm going to go back and start this one. Okay, so there's nothing... You could divide everything by -1, but you might as well just leave it, okay? And so you would end up squaring both sides. Okay, so first of all, when you square a negative, what does it become?
Positive.
Positive. And then when you square a square root, it's just going to be by itself. So that's x plus 1. Is everybody okay at that side?
Yep.
Okay, what do you do when you have x plus 1 squared?
X squared. Distribute the 2.
No. So anytime you have like a plus sign here, you're going to have to use your FOIL or your box method. And so this right here actually means x plus 1 times x plus 1. And so it's up to you on which method you want to do to multiply that. You might actually be able to do this in your head, but it becomes x squared, and then 1 plus 1 equals what? 2. So that's plus 2x, and then 1 times 1 equals 1. So plus 1. Okay, are there questions? And then what would I do now in order to solve this?
Subtract the x and 1 plus 1.
Good. Subtract x and subtract 1, and so that we have it set equal to 0. So those cancel. We get x squared. What's 2x minus x? Just x. And then the 1's cancel. Yes,
Do
Jordan.
the box method, I thought 1 plus 1 is 2 at the end, so it would be x squared plus 2x plus 2.
Let me see here. So when you're at this, you have
Oh, that's
x.
right, you multiply. I'm stupid.
You want
Oh, yeah.
stupid, Jordan.
So to get inside the box, everything is multiplying. Okay, so this does not have 3 terms, and so it's not like what multiplies to be something and adds to be something, but what do you always do when you're factoring? GCF. So is there a GCF here?
X.
X. So we take out an x and we're left with x plus 1. And then when we set those equal to 0, we get x equals 0. And then this one will be x equals what? -1. So when we go back and check, one of these values may not work, right? And so let's go ahead and do the check. So if we plug in 0, I'd have -0 plus 1 equals 0 plus 1. So 0 plus 1 makes 1. The square root of 1 is 1, but does -1 equal 1? No, right? So 0's out. So hopefully the -1 should work. So if I have negative root -1 plus 1 equals -1 plus 1, Negative 1 plus 1 is 0. Negative 0 doesn't exist. 0 is just 0. And negative 1 plus 1 is 0. So that checks out. So that means that my answer is negative 1. So if I'm going over to graph this one, remember this is in the form y equals mx plus b. What is my b value? So when I'm graphing my line, I go up 1. What is the slope now on that equation? 1. So we're going to go up 1, right 1. Or we can go down 1, left 1. And we'll draw that line. Okay, and so when I'm graphing this one right here, what would be my vertex? Good. Negative 1, 0 is correct. So, negative 1, 0. And we can see that it looks like they're intersecting right there at that point, right? We can do a t-chart. Do you guys agree? And what value, if you were going to do a t-chart, what could we plug in? We could do 3. Okay. So if I plug in 3 for x, 3 plus 1 makes 4. The square root of 4 is 2, but because there's a negative in front, it would be negative 2. So 1, 2, 3, negative 2. And why is this one curving down? Because of the negative in front. Remember, the negative in front makes it reflect. Okay, and so this is reflecting over the x-axis to the other direction. And the two graphs intersect at x equals, yes. Or, yes, negative 1, sorry. Okay. Any questions there? No? Okay. So we should know how to do most of these problems, but we're just going to go through them to make sure. So remember, we're always attempting to get our roots by themselves. So what would be the first thing I do on this example? Good. Add 1 to both sides. These cancel. I have 1/4 root x plus 11 equals 2. What will I do next? Very good. So I multiply by 4 in order to get rid of that fraction. Also, in order to get the root by itself. So that cancels out. I have root x plus 11 equals 8. Next, what will I do? Good. Square both sides. X plus 11 equals, and 8 squared is?
64.
Good. And then we'll subtract 11 to both sides. And x equals? Good. And then we can plug it back in to check our answer. So that means I'd have 1/4 root 53 plus 11 minus 1 equals 1. So 53 plus 11 is what? 64. And what's the square root of 64? 8. And so we have 8 over 4, which is what?
2.
Good. And 2 minus 1, does that equal 1? Yes. So it checks out. So x equals 53 is correct.
Where did you get 8 over 4?
Yeah, that's why I should be 8
Oh,
over 4.
because the
Yes. Sorry. So the square root of 64 is 8, and since it's multiplying times 1/4, so 1/4 times 8 is really 8 over 4, which reduces to 2. Sorry.
No, it's okay.
Okay, what will I do first on this other problem? Good. Subtract 4 to both sides. So I have 5 cubed root of x minus 1 equals 10. Next, what will I do? Good. Divide by 5. So now I have the cubed root of x minus 1 equals 2. How do we get rid of a cubed root? Good. Cube both sides. So I end up with x minus 1 equals, and 2 cubed is 8. We add 1 to both sides, and so I find that x equals 9. When you are taking your test, it's a good idea to always check your answers. But for the most part, but not always. That's why you always want to check them. It's normally when you have two answers that one of them won't work. Okay? So for time's sake, I'm just going to do the check really quick. So 5 cubed root of 9 minus 1 plus 4 should equal 14. What is 9 minus 1? 8. Cubed root of 8 is 2. 5 times 2 plus 4, we get 10 plus 4, and that does equal 14 and checks out. Okay. Is there any way of getting this root by itself? Or these roots by themselves? No. So what am I going to do? Just square both sides. Okay, the thing we have to be careful about though when we're squaring both sides here is that the number that's not under the root also needs to be squared. So that means I'm going to end up with what? 9, and then times whatever was in the root, which is 5x plus 1. And then over here I'm going to end up with 16 times 3x. Good. To solve now we would distribute, and so 9 times 5x is 45x plus 9 equals 48x, right? Then I will do what?
Subtract 45x.
Good. And so I have 9 equals 3x, and then I will,
Divide by 3.
good. And so my answer is x equals 3. Okay. So let's go ahead and just do our check real quick. So 3 root, and then we have 5 times 3 plus 1 equals 4 root 3 times 3. So 5 times 3 is 15, and 15 plus 1 is 16. And what is the square root of 16? 4. And then over here, 3 times 3 is 9. Square root of 9 is 3. So does 4 times 3 equal 3 times 4? Yes, let's check out. All right, last one over here. What will I do?
First you subtract 2x
Square
from both
everything.
sides.
Yeah, we could subtract 2x to both sides. I personally think, though, that it might be easier to make this positive. So could I instead add 5 root x to both sides?
Yes.
I'm just trying to make it a little easier. And then at the same time, I could also, I'm just going to write this out, though. So we'd have 2x equals 5 root x plus 3. And then I could subtract 3 to both sides. If you wanted to do it the other way, you could. You just end up with lots of negatives. So 2x minus 3 equals 5 root x. Okay, so what do I do now?
Square these out.
Good. Square both sides. So what happens when I have, this is called a binomial, when I have two terms here,
Box method.
I have to do the box method. Okay, or FOIL, however you decide that you want to do that. And so, do you guys like the box method best? Okay, so I'll make a box, and we have 2x and negative 3, and we're writing that twice because we are squaring it. And so I get 4x squared minus 6x minus 6x and a positive 9. So, and this is like terms, right? And so we end up with 4x squared minus 12x plus 9 equals what?
25.
35x.
Good. What will I do now?
Subtract 12x.
We're going to subtract 25x. Good. Because we want it set equal to 0, and we always want our x squared to be positive. So I have 4x squared. When I add those up, it makes what?
37.
Yes. Negative 37x plus 9 equals 0. Do you guys remember how to factor this?
Fine.
Good. So we go 4 times 9, which makes
36.
36. So we're looking for a number that multiplies to be 36 and adds to be negative 37. What works?
36 and negative 1.
Good. Negative 36 and negative 1. So remember how we write this out now? It's like the grouping method.
Hated the diamond method.
Well, I'm not actually using the diamond method. I'm just kind of writing it out there. But we're going to write this as 4x squared. And then we're going to have a negative 36x minus 1x plus 9. So we multiply this over to help us figure out what the middle is going to be, but then you keep the front and the end the same. Are we good? And then do you guys remember what we do at this point? Group. So what can I take out of my first group?
4x.
Good, 4x. And I'm left with,
X minus
good. And then my second group, what will I take out?
-1,
Good, -1. And then I'd be left with
x minus
x minus 9. And so remember that this is now my GCF, is x minus 9. So when this factors, it is x minus 9 and 4x minus 1. And when we set that equal to 0, what does x equal? Positive 9 and positive 1/4. So since I have two answers, there is probably a good chance one of them is not going to work. So we're ready to check it out? Okay, so going back to our original problem, which is right here. Let's go ahead and start with 9. So I'd have 2 times 9 minus 5 root 9 equals 3. Okay, so 2 times 9 is 18. The square root of 9 is what? 3. And so I end up with negative 5 times 3, which is negative 15. And does that equal 3? Yes. Okay, so let's go ahead and check the 1/4. But I'm pretty sure that the 1/4 is not going to work, because normally only one of them does, but who knows? Both of them could. So 2 times 1/4 minus 5 root 1/4 equals 3. So 2 times 1/4, do you guys know what that reduces to? 0.5 or a half. Do you guys know what the square root of 1/4 is? 1/2, because the square root of 1 is 1, the square root of 4 is 2. So that means we're going to end up with negative 5 times a half, which is minus 5/2. Do these have, since they have common denominators, we can subtract. 1 minus 5 is negative 4. So I have negative 4/2, which reduces to be, and does negative 2 equal 3? No. Okay, so this one does not work, which means 1/4 doesn't work, and my answer is just